my talk, Repo 911. We're going to be talking a little bit about repositories that have gone horribly wrong. This is going to be based off of a lot of experience that I've had working with GitHub Enterprise customers as a services engineer, helping migrate to GitHub Enterprise, configure, and rescue repositories that may need some help. When we came up with a name for this talk, I realized afterwards that some of the context may be missing here in Europe. Repo 911 is a little play off of an American TV show called Reno 911. It's a police action comedy TV show, and 911 is our emergency phone number in the United States. I think here in Europe it's like 0118999881199. 9119725 All right, cool. I did not memorize that for this talk. Just a really big IT crowd fan. So for those of you who were here earlier for the workshops, you're like, oh, it's this guy again. What's he going to do this time? Jump into an IRC channel to try to get help with talking about whatever it is he's doing. For those of you who are not here earlier, I am Kyle Macey. I am a services tools engineer at GitHub. It's a team that was just created last week. I kind of shifted over into this position. We're working on some really cool tools for getting started with GitHub, migrating into GitHub, making it easier for people to just launch and go with it. A little bit of a personal plug here, shameless plug. We are hiring another services tools engineer. So if you like Git, but you're also semi-proficient in, Subversion or Mercurial, come talk to me later, and we'll see about if you could be a cool fit on the services tools engineering team. It is a remote position. You don't have to hang out with me in Rochester or in San Francisco. Yes. Before we kind of go into what sort of scenarios we're looking at, I want to kind of introduce the tools that we're going to be using today. The first being the BFG repo cleaner. This is a Java-based utility that is an alternative to Git filter branch. It is specifically targeted towards removing large files from repositories and scrubbing sensitive data from your Git history. This is a great way to either audit out things from your commit messages or from, not from your commit messages, from your commit history, as well as increase the performance of your repository. And we'll talk about that a little bit more in a second. Also introduce Git filter branch. Doesn't have its own website, but it has a man page. Now that I said that BFG is an alternative to Git filter branch, as I'm sure many of you know, does far more other cool things, and we're going to use this to scrub garbage out of Git commit messages, and we'll see why we might need that in a minute. We're also going to be taking a little bit of a look into Git-lfs, which is this awesome utility that I think was just developed in the past year or so. I think there's actually some people here that work on it. Can you raise your hand if you work on LFS? I thought, no? They're not in the room. Oh, good timing. They're like, ask them questions to make them raise their hand, and that went toward, all right. So what essentially Git-lfs does is it allows you to host large files in a blob storage and have much smaller files in your Git repository that just kind of points to these larger files and download them on demand, so you're not pulling in these giant files every time you're cloning or checking out or what have you. So where does this need come from? A problem tends to arise when we start putting large binary files into Git. This could be like build artifacts. This could be your project assets, your class files, things that Git wasn't necessarily built originally to handle. We all know that Git is super fast, but a large part of that is because it was built with the assumption that we would only be versioning source code, and some people have a tendency to gently ignore that and put other things in there. And so when we start putting these large binary non-versionable files into Git, it starts to slow down considerably. And especially your network operations, we talked a little bit about cloning, can take a very long time. Pushing and pulling, anything over the wire can take a long time. If you're cloning for your continuous integration, you may be waiting a day and a half before your build is done. Even your local operations, depending on how much you've stuffed into this repository, checkouts, commits, all these things can take a lot of time, and we'll look a little bit into that as well. So for this workshop that we're doing, I've put together a little example repository that reproduces some of the issues that I've seen out working with customers. They're all very arbitrary. The large files are just random bits strung together, and don't have any real meaning, but it kind of helps illustrate some of the scenarios that you might walk into. There is a GitHub URL here, but full disclosure, I accidentally pushed up the cleaned, smaller version of the repository shortly before this talk. And in order for me to put the large, ugly 1 GB repository back up into GitHub, on the conference Wi-Fi would take approximately 6 to 7 days. And as much as you would probably love to sit here and watch that happen, unfortunately, I don't feel like entertaining that. But let's take a quick look at what this project looks like. I've got it cloned down. So here, to explain how we're going to make this work, I have the repository cloned down locally into a root folder. A lot of the commands that I'll show you will be using the GitHub URL. When we actually put them into the console, we'll be cloning from that local repository, so that way we're not waiting, a year and a half for things to download. And you can kind of use your imagination and pretend we're using github.com. So if you take a look at what's in here, it's nothing terribly impressive. We have an assets directory with an image.psd. This might be something somewhat familiar to you, and just something that's a binary file, doesn't version very well in Git, especially if it's a larger file. Whoever was doing this repository here was checking in their build artifacts, right? And you may have seen this before. If you're asking yourself right now, why is a Ruby project generating WAR files, you're concentrating on the wrong thing. Again, arbitrary, just kind of wanted to make an example. Our actual source code is only just like our one file, project.rb. We can bring that bottom up again. This is going to be like the last talk all over again where I tried to figure this out. And this time Hector isn't here to help me. That's all right. It's okay. We'll figure it out. We'll fix it in production. I just put some scripts in here that kind of help me build this repository. We have a build script here. Oh, come on. Ah, all right. I know that's kind of low. Now I really want to fix this. I'm sorry. Get up there. That's not what I want you to do. Hold on, hold on, hold on. How do you, what? Just press up? Yeah. Oh, look at that. Please, like if you want to team up sometime. This guy. Occupy Mars. That is a great shirt. Thank you. All right, yeah. Anyway, so we have this little build script here. As you see, all it does is make sure that the build directory exists and takes some random data and chunks it into a file there. If we looked a little bit as well, we also had a script commit, which is also, you wouldn't believe it, but this is something that I've seen before in the real world where they don't bother to teach developers how to use Git. So they give them one shell script that they can run that adds everything in the directory and commits it. And then because they want to protect their intellectual property, they put a little message at the bottom at every single commit. Some companies will go so far as to have CI to make sure that you don't take that message out. And the last file in here is just what I used to generate a whole bunch of these commits. And it's just a simple, and I tried to make it look like it happened over time by doing like this date time jump here. But it's like some automated things here. Another thing that you might see that this kind of represents is machine commits. Like you might have a CI or some other server that will generate commits and push them up indiscriminately. So you may run into this. So out of all these things, does any of this look familiar to anybody? You raise your hand if you've seen stuff like this. Okay, got a few hands. All right, does anybody think this is a good idea? Okay, good. Just making sure we're all on the same page here. So let's go back in here and present. Okay. Now, before we get too far into how we're going to fix this up, I do need to let you know that we're going to break it first. Essentially, the changes that we're making here are going to be modifying our git commit history. Okay, so when we're done with reducing the size of this repository and we push it back up, we're going to have to either force push or create a new repository. So some things that you might, if you're thinking of doing something like this, you may want to consider locking the original repository, telling your developers and your coworkers to take a day off while we try to reduce the size of this repository. You may want to, like I said, create a new remote for pushing up the reduced size one. Back up everything. This is a destructive operation. And yeah, like I said, take the time off, because if they keep working, it is possible to take those new commits that they were doing on the old large Git repository and patch those onto the new fixed one. But it's probably easier to just have them hold off for a day or so. Otherwise, you'll be dealing with all sorts of issues otherwise. So yeah, we're going to start by removing those big old build artifacts that we found in there. Each of those build artifacts is about 30 megabytes. We're going to be using the BFG repo cleaner that we talked about a little bit before. If you're interested in downloading that and checking that out, there is the link to the GitHub pages page. And we'll take a quick look here at the first steps that we're going to take. And so first, we're going to take and see how big this repository is. Since we're not doing any remote operations, it's kind of hard to demonstrate how this might be affecting your day-to-day work by slowing down your commits, pulls, and pushes. But I think just the illustration that we can't interact with this repository on GitHub.com at a conference is kind of a sign that there's something wrong here. It's too large to deal with, or what have you. So we're going to take a look and see how big it is. And then we're going to make a new commit that deletes those build files from our repository. And a lot of you may be like, hey, Kyle, that doesn't actually reduce my repository size because they're all in my Git history. And that is correct. We're going to be dealing with that with the the BFG repo cleaner. And BFG has this failsafe built into it that if you do not delete the files ahead of time, it will leave them in your master branch as a failsafe. It wants you to be proactive and have a commit that deletes those files first, just to make sure that you do. Like I said, it's very destructive, just to make sure you're doing exactly what you want to do. So we'll be adding that commit to remove those files. And just because I'm good at cheating, ta-da! You can pull that up. All right. So if we take a look at the size of this repository, du-sh takes a directory and gets you the recursive total file size of that directory. The .git directory is where all of your Git objects are actually stored. So this will give us a good idea of what the Git repo size is on disk, both on your remote and for new clones. So if we take a look at that, it doesn't show up on my screen, but it does show up on yours. We have a 936 megabyte Git repository. And for context, if you're curious, when I first pushed this up with my internet back at home with 15 megabits up, it took 25 minutes to push the repository. So that's no good. But as we see here in our instructions next, we're going to git rm build star.war, and just to be explicit about what this command is doing is that it is removing the files from the build directory that match the .war extension, and also stages those deletions for commit. So we'll run that, and we get a little bit of output here. If we run git status, you can see that these changes are staged. We've deleted these files. And I'm just going to copy pasta right there, committing that in. Okay. You can even see that that commit took a few seconds there. But so now that we have those files deleted, we're going to push that commit back up to our origin. Actually, let's do that first. There we go. And it did go pretty quick. As you can see, it's cloning or pushing right up to a local directory here. So it's all on disk, all pretty fast operations so far. Also pretty convenient for giving a talk about repositories that run slowly, because I don't have enough jokes to entertain you while we push things. So yeah, going back into presentation here, we've deleted the files. What are we going to do next? We're going to make a new clone of the repository. We're going to do a mirror clone. This only pulls down the Git data. There is no working directory, and I'll show you what that looks like if you're not familiar in just a moment. We're then going to use the BFG utility to delete files matching the war file name extension, and this will go through and delete them all the way back through your history. So even if there are multiple revisions of these files, it'll go back to the beginning of time as if you had never committed these files into your Git repository in the first place, and disassociate these objects from the Git index. Now, once we've disassociated them, they're not technically deleted off of disk. This next little command here tells us that any loose objects that we have, we're going to expire them in cache immediately, and then run the git gc garbage collector and delete those files off of disk and out of the Git index. And at that point, we should be able to take another look at the Git index and see that our repository size has drastically reduced. In this case, we're not doing .git because we are already in a Git directory. Once these files are cleaned out, we will push up the clean repository back to our remote. So let's see how this all looks. All right. So I'm going to cd back up here. Our fresh mirror clone there. And we're going to run the BFG utility from outside of the directory at first and tell it to point right into there. So this operation is going to go through, delete those files from history. It gives you a little bit of a report here, but as you can see, it has also generated this repo 911 git BFG report. If you can see that on the bottom right, in fact, we'll do that. And in that directory, there's more details as to which files were deleted, which were mapped. And I'm sorry, not files, but Git objects were deleted there. So if you're going through and auditing, you need to present something back or just keep good track of what you've done. There's some very good useful information in there. And we'll cd into that repository. And I told you that I would show you what this looks like if you hadn't seen it before. Inside here, we have essentially the contents of what that .git directory would be. So we have all the Git objects, the pointers and stuff right in here. But we can run, before we get there, we have to run our garbage collection. And, all right, everybody's going to giggle, I think, because this didn't work right earlier. And then I'm going to do something that some people might frown at me for. Oh, no, it worked. OK, perfectly fine. Cool. So we've reduced our repository from 900-something megabytes down to 11 megabytes, making this much easier to push and pull and clone and just deal with overall. So in order to send these changes back up to our remote, we can simply run git push. Little disclaimer here. When you run git push from a mirror clone, it will automatically push it to all of the remote branches, and it will force push as well. So there's no need to designate that when pushing back up. So it is going to overwrite the changes on our remote here. And you can see that happening towards the bottom, where it says we've force updated both master and this release branch here that we've created. Okay. So that's all well and fine. Let's find my mouse. Come back here. And just to make sure that we see that this is working correctly in the way that we expect, we're going to do a fresh clone of the working directory Git repository, and we're just going to peek inside there real quick and see that everything is removed as we expected. Okay. All right, so we're in there. We run ls. We no longer see that build directory. It has been removed. And if we run git log and we try to grab one of those commits that created the build artifact, you see that there? I'm sorry, just to kind of point out, these are these automated commits that we had earlier, creating these build artifacts. You can see the messages down there. The commits still exist, but if all goes well, we should see that nothing has been introduced here in these changes. It has gone back through the history and completely removed those files. So we got those war files out of the way, and that was probably the big majority of it. So what are we going to do next? We're going to take a look at using the BFG repo cleaner to take our assets files, that image.psd, and we're going to add that into Git-lfs. Again, this specific assets file, we can take a look in a second, has 2 revisions, which means both full binary files are saved in our Git index, essentially doubling the size of that object in our Git repository. So if we were to add that file to LFS now, future iterations of it would be tracked by LFS. However, without using something like the BFG repo cleaner, all those past objects would still be in your Git index. So it's going to essentially go back in time and pretend as if you were using Git-lfs from the very beginning. And if you're interested in a little bit more on LFS, there is the URL to the documentation and download page. And essentially what we're going to do here is I'm going to grab a brand new mirror. Actually, we don't even need to do that. We can use the one that we already have. We're going to skip those first 2 steps. I just bought you back 30 seconds of your life. And then we're going to use the BFG repo cleaner. It has this flag here called convert to git-lfs. Much like we did with the war file, we're going to give it essentially some sort of regular expression or glob matcher to find the files that we want to start tracking with LFS. This no blob protection flag is one that you can use for deleting files. But essentially, remember when we said we have to delete the files before we try to, delete the files with a commit before we use the BFG repo cleaner. The no blob protection essentially takes off that safeguard because we don't want to delete the file, but we do want to replace it with the LFS version. Once we've done that and we've given BFG that designation, we're going to go into the repository and install git-lfs into it. And then we'll verify that that worked by running the git-lfs ls files. That'll tell us what files are now tracked by LFS. Because we're doing a local clone here, I can't actually demonstrate it pushing or pulling LFS files in any sort of reliable manner. But there may be, I just wasn't able to figure that out with kind of my recent discovery of having to do this locally. But we'll push that back up to that remote. So let's go do that. And oh, sorry, we should be up one directory. There we go. And much like we did with our deletion here, we do get a report kicked out for us. You'll see that it's made a new directory on my local here, reporting everything that was added to LFS. You have a record of everything. And it's pulled that file out, started tracking it with LFS, and replaced it with a pointer file for LFS to use. So if we cd into that repository, we can now install git-lfs into it. And we'll do that. There we go. Very simple return message here. It worked, basically. That pre-push hook is what kind of checks to make sure that the things you're sending up is both raw Git data and LFS objects. And yeah, we can push back up to our local remote here. Yeah, we're good. So these are those LFS errors that we're getting because we're doing this locally. I apologize for the errors we're getting there. Okay. So kind of getting towards the end of our process here. The last thing we want to do is clean up those commit messages. You know, we had that confidential data descriptor at the bottom there. You may have that from some sort of automated commit process. You may, in the past, have used Jira and put Jira tickets into your commit messages, and now you've switched to something else, and we're like, we don't need that in our commit messages anymore. You may have used a tool like SVN to Git-SVN to come from Subversion, and you get those little SVN or Git-SVN ID comments at the bottom of the commit messages. You may want to prune those out. There's a whole bunch of various reasons why you might run into these. So again, we're going to kind of take a look, and we can continue to use our local copy here. We don't need to reclone. But we're going to use that git filter branch that we talked about. And we're going to use the message filter to essentially go through and run this sed command. Essentially a regular expression replace. We're going to put in the text for that confidential coding information into there, and we're going to replace it with nothing, essentially just trimming it out. And the all flag, if I'm not mistaken, tells us to go across all the branches. If you really want to know why I'm not entirely sure, because I did find this on Stack Overflow, which I'm quickly becoming famous for, I think. So yeah, we'll run that last little bit here. Oh, golly. There we are. And so we'll plop that right in. You can see I've already pre-prepared the exact command that we would need to remove that little disclaimer at the bottom of the commits. Actually, before we run this, I'll run a quick git log so we can see that again. So if oh, it looks like we have other stuff in there too from, man, that would have been good to include in this. Sorry, and now I've done it. Okay, but we still do have our commit contains strictly confidential coding information, and we could use. In fact, we can probably just do this, you know, live. Why not? And remove those former commit IDs from there if we would like. And we'll clean up these commit messages here, making them a little bit neater, a little bit more informative. So let's run this first one. There we go. If we look back in the log, yeah, that was pretty cool. You guys are really excitable sometimes. So now is something totally unplanned and newly discovered. Why don't we try to take this out of here? Because this doesn't look like any fun. It's probably useful for somebody. But for the sake of taking risks and chances, we will go right in here and, what's the best way to do this? Oh golly. Just delete that right out. Somebody right now is like, I know some sort of shell shortcut that would have deleted that with like 2 keystrokes. Oh, thank you. Sorry. Here, let's. Oh, now I got to do it again. Good job. I'm gonna type it out this time because Command W guy is like, or Control W guy is gonna like get frustrated with me. How are we doing? We're doing good so far? You know, when I was doing services engineering and I worked with customers directly very often, we don't actually ever touch keyboards as part of our agreement. We just kind of coach people through running commands. So I like to tell people that my job was being a backseat typist. And you'd catch people all the time. You'd start to feel terrible after a while. I'm like, you spelled that wrong. I did it a Hector earlier in a talk. It's just like habit now. This looks like it'll work, right? Anybody? I missed before the asterisk? Oh, is it? I thought it was a regular glob, but yeah. I trust you. Okay. If that looks cool to everybody, we can run that and see what that does. I mean, worst case scenario, you know, it's just a demo repository. Let's clear this up. We're going to run git log again. Take a look at what that looks like. Oh my goodness, look how nice those commit messages are. Yeah. And you could do this to do the opposite sort of thing. You know, you could go and put stuff into your commit messages, but that's no fun. All right, so now we have this nice clean repository. We've taken our assets, we've put those into git-lfs. We've taken our large build files, we've moved those out of the repository entirely. In case you're curious, like where should those live? Those should be saved on some sort of artifact server, either blob storage, completely separate. Don't commit your build artifacts into Git. And yeah, so with this brand new repository, a little bit of downtime for our developers. We should be back up and running soon, saving ourselves a lot of time with day-to-day operations. And that, my friends, is the end. Do we have any questions? Yes.
Oh, hi.
Oh.
So what would happen if, when the employees come back, they commit back all that history back, or is there a way? What would happen if a dirty repo was pushed back up?
So they would have to force push back up in order to put back up that mismatched commit history. If you're using GitHub, you can disable force pushing. I think other Git products allow you to do that as well. So you can prevent them from just undoing everything that you just did. And so, but yeah, there's definitely a process you would want to go through of making sure that everybody's aware of what the downtime is for, and give out instructions on how to switch to the new remote, make a fresh clone. It should take them minimal time, since you're cloning down a much smaller repository versus a giant 1 gigabyte. And saying the 1 gig repository reminds me, the 1 gigabyte is the maximum for GitHub.com. I think the largest I've seen, actually working with a customer on GitHub Enterprise, which they can set their own limits, is upwards of 50 gigabytes. So if you've ever wanted to do git clone and then take a vacation, I might tell you on the side where that was. Actually, it's fixed now, so tough luck. Any other questions? None? None at all? You'll check Stack Overflow. Yeah, there you go. Absolutely. Well, thank you very much for your time, and enjoy the rest of Git Merge. Thank you.